These are the video notes for 2A, geometric sequences. And a geometric sequence is a sequence that changes by a common ratio each term. You can also think of common ratio as being like a common multiplier. This is different from an arithmetic sequence because in an arithmetic sequence, these are our notes from arithmetic sequences, that was with a common difference. So in arithmetic, you're adding and subtracting by the same amount each time. Geometric sequences, you are multiplying by the same amount each time. So for our example, we'll put it into a table first, and we'll have the first term be 6, and then the second term will be 12. The next term will be 24, after that 48, after that 96. So since it's a geometric sequence, we're not adding by the same amount each time. It's going up a lot faster than that. So then you can think, okay, but am I multiplying by the same amount each time? Well, to get from 6 to 12, we're multiplying by 2. To get from 12 to 24, we're multiplying by 2 also. To 24 to 48, we're multiplying by 2, and from 48 to 96, we're also multiplying by 2. So I can say that my common ratio, and underneath ratio, I'm going to write multiplier, so that way I can remind myself that common ratio is kind of like a common multiplier. In this pattern, it's 2. And that's why if you want to write a recursive function for this, it's pretty straightforward because it's just whatever f of n is, it's the previous term times 2. And we always have to say what the first term is. In this case, f of 1 is 6. So that's our recursive function right here. And for our explicit function, it's a little trickier, but we can think of this as, so in our first time it was 6. So we just had a 6. In our second term, we took that 6 and then we multiplied it by 2. I'm just going to draw these lines in so that it's clear for you to see how this is working. The third term, right, we started with that first 6, then we multiplied it by 2. That's how we got 12. And then the 12, we multiplied that by 2. This fourth term, right, we started with 6. Then we multiplied it by 2 to get 12. Then we multiplied it by 2 again to get 24. Then we multiplied it by 2 again to get 48. For this 96, how did we get there? We started with 6. We multiplied by 2 to get 12. Then we multiplied by 2 again to get 24. Then we multiplied by 2 again to get 48. Then we multiplied by 2 again to get 96. And so these terms, you can think of this first one as being 6 times 2 to the 0 power. Right? This is equal to 1. So this is 6 times 1, which gives us 6. This one we did 6 times 2 once, so 2 to the first power. This one we did 6 times 2 twice, so 6 times 2 to the second power, This one we did 6 times 2 3 times, so 6 times 2 to the third power. This one we did 6 times 2 to the fourth power. And notice that the number of times that we multiplied the first term by our common ratio, right, that power is equal to whatever the n value is minus 1. Right? 6 times 2 to the second power, that's the n value of 3 minus 1, which gave us 2. 6 times 2 to the third, well, that was when n was 4, because 4 minus 1 is 3. 6 times 2 to the fourth, well, when n is 5, 5 minus 1 is 4. So that's why for our explicit function, we can write f of n is equal to 6, which was our very first term, times our common ratio, or our common multiplier of 2 to the n minus 1 power. I'm going to annotate this. So this is when n is equal to 1. That's your first term. This is your common ratio. And the last thing that we'll put in here is a graph. And the main thing that I want you to see when you're doing a graph is we'll do 25, 50, 75, 100. That, oops, sorry, just 50, not 500. We'll do 1, 2, 3, 4, 5. So 1 is 6, that's really low. 2 is 12. 3 is 24. 4 is 48, and 5 is all the way up here, 96. So notice how this graph, if you drew a line through it, it's not going to be a straight line, because with geometric sequences, it increases a lot faster, so it curves up. And that's how we represent a geometric sequence.